So I'm going to be talking about compilation today. I want to know before I start, how many of you like to drink coffee? Ooh, cool. Hope you are not too stuffed with your food and not sleepy, so you can still survive this talk. I'll try to make it as interesting as I can. But I skipped my lunch so that at least one of us stays awake, because it wouldn't be cool if all of us fall asleep and then Noam cannot come to the stage after me. So I wanted to show you a demo first. I built this API called Coffee API. And before I started, let me just quickly build it. Since everyone is building bundlers these days, I decided to give it a go myself. Don't worry, it's not built with Rust like everything else these days, but it's using some top-of-the-line hashing mechanism. So it will take the current timestamp, and we'll use this information to... There's some microphoning. We'll use this information to find the prime number, and then we'll use this prime number and feed it to ChatGPT to get a special word from War and Peace, because that's the longest book I could find that has all the prime numbers in it. And then when we have this word and the number, we can use this information for hashing. Now, I think that compilation is very important. How many of you like to compile stuff? Not so much? I think it's very important, especially when your compilation succeeds. And when these things happen, it's something that you should remember. It's a special moment in anyone's life. So I thought it could be cool if we could have some sort of a memory, like a memento of this time. So we use this information, this unique information, to generate a Midjourney image. So you can always come back to it, look at this image, and remember that time when your compilation succeeded. So it will take just a little bit longer. Okay, just a few more minutes. Oh, hey, thank you for the coffee. Yeah, drinking coffee is the perfect time during the compilation. Okay, it's done. Perfect. How many of you ever thought, what is the thing that is causing all the procrastination for developers? Like, what are these things that cause you to stop your work and to procrastinate? Spoiler alert, it's none of these guys, though. Depending on your preference, some of these websites can take a huge portion of your time. Now, it's usually these long processes that kick you out of your zone, that kick you out of your focus, and force you to think about something else, to start Googling or doing stuff, or go for a coffee break. And usually we blame our tooling, like Webpack is too slow, so let's build RSPack or TurboPack, or my ESLint is too slow, so let me use Rome, or we switch everything from JavaScript and TypeScript to Rust, thinking that would make things faster. But the sad reality is that no matter how fast our tools are, we always manage to employ all the CPUs and fill all the memory with our processes. The problem is not in the tooling, it's with us and our architecture. So today I'm gonna show you a couple of tricks, what you can do with your projects to make them faster and to actually have the size of the project work in your favor and not against you. You already heard a bit about me, so my name is Miroslav Jonaš, or you can just call me Miro. I work at NX, and today I'm going to be talking quite a bit about NX, so don't worry if you don't know what this is. So let's build a coffee delivery API. Now, usually we start with a monolith. And then we realize, okay, we need some endpoints, some controllers, so we add users, orders, products, and then users might have account, and then orders have a payment, and products have a product list. So it starts slowly splitting this big monolith into some domain-driven chunks. And then we might have different payment methods for our payment service. And when we look at all these chunks, we can look at them as a separate subfolders of our API application. Now, this is still a monolith, but what would happen if we would now see how these things are connected? And let's say into each of these folders, we add one just config. And now I can test each of these folders separately. I don't have to test the entire application as one chunk. It's still one application, but I can test each folder separately. Then I can say, okay, if I changed account and I test it, and then I change something in product list, there's no point of testing everything again. I just need to test this bit that I changed, right? And then we can run the test. Similarly, we can also create tsconfig and bundle this small chunk. And then we can use these bundles to stitch them together to create our final application bundle. Now, we can do the same thing, right? You can do tests for everything, lint for everything, build for everything. Even our application can then have deploy. And we want to test the entire application, so we can add end-to-end application that has lint and serve, which actually runs our Cypress or whatever test you're using. Now, let's say we want to build products. Based on this diagram, we can see that in order to build products, I need to build product list first. So I build this once, and then I can build products. But since I already built product list, I don't have to build it again. I can just keep building my products without changing the product list. Now, let's say I want to build orders. So I build orders. Since we already have product list built, I don't have to do it again. I can just go on and build orders. Now, if I change something in the orders, again, why should I build product list? It's already built, so I can just keep using the bundle that I have, and I can just keep building. And this is all cool, but it contains a lot of magic that only you as a core developer know. How does things connect to each other? In which order they need to be run? Don't worry, I didn't steal this slide from Eric. It was there already. So let's look at our diagram again. If we want to build orders, we know that in order to build orders, we need to build account, payment, and product list. And then in order to build payment, we need to build method PayPal and method Stripe. So the correct order would be first the methods, then account, payment, and product list, and finally we can build our orders. Well, this is all interesting, but how do we know how these things are connected, right? We can see it on this diagram, but where's this diagram? Where does it live? It's actually all in your code. So if you look at your files in the orders folder, you would see that there's some import going to your TypeScript alias pointing to account folder, payment folder, and product list folder. And similarly, in your payment, you might have something like this, some lazy import based on the type of payment, which loads either from your Stripe folder or from the PayPal folder. So it's already there in your code. You just have to read it. And this is where monorepos come into play. Because you don't have to do this manually. We build this for you. We'll analyze imports, follow all the dependencies, and based on that, we can construct this up-to-date graph. So your diagrams no longer have to be outdated, sitting somewhere on some network drive. You can always have up-to-date graph. And it's also interactive, so you can click on certain parts and see what is the subgraph of connected things. So when we look at this entire diagram, and let's say we made change to the method Stripe. Again, based on the diagram, we know that the only thing that could have been affected by this change is the payment. And if payment has been affected, well, potentially orders are affected as well. And if orders are changed, then maybe application is affected. And if application is affected, well, we should probably test it to make sure that everything is still working. So just by doing one single change, you can see the entire chain of changes that happened. But the cool thing is not about this long chain of potential changes. It's about all the other things that weren't marked. Because by knowing how things are connected, you know that you only need to check this chain and nothing else, because nothing else could have been affected by this change. So if I just change that single project and I run my build for all projects or for my application, you can see here the list of the projects that were just taken from the cache because they were not changed, and then the remaining projects in the correct order, orchestrated one by one. And you might be thinking, okay, but how does this work at all? We use just simple git diff. We compare the last git with your current state. We see what files have been changed from the previous commit. And then we see, okay, where do these files belong to? Which folder they belong to? And based on that, we can say, okay, so this is the chunk that has been changed. Okay, now tell me what parts depend on this single project or this single folder. And based on that, we can get the entire tree. Now, it's a bit tricky when you do this on CI because your last commit and the one that you're trying to check the changes for are actually the same. So there's no comparing to the last commit because your last commit is the commit you just pushed. So normally you would assume, okay, I should probably compare it to the previous one. But if it's PR branch, you probably want to compare it all the way back to the branching point, right? But at least for main branch, it's easy, right? It's simple, you just compare it to the previous one. But is it? Because previous one could have been broken. And if you just compare it to previous one, you would be swallowing that error. And that's not cool. And also, the one before that might be pending. So you want to actually find the last successful one. And luckily for you, we provide tooling that uses underlying GitHub APIs and CircleCI APIs, for example, that will find that last successful commit. We'll take the SHAs, we'll see what files have been changed in between those two commits, find what projects have been, who these files belong to, and according to that, we'll tell you this is the list of affected projects, run commands only on this set. Now, if you're watching a football match and your favorite team scores, and then on TV usually they show a replay, wouldn't it be funny if suddenly goalkeeper would save the goal? Like, that doesn't happen, right? So why do we expect that thing to happen in development? If I run the build on my machine, I get some logs, I get some artifacts. But if I run it again, why would I expect something else? If I didn't change anything, there's no point of generating all that stuff again. I can simply cache the results, and then when I run it again, just get the results back from the cache, both logs and the artifacts. Now, I can be running some command like build, and then I might have some colleagues like Trinity or Mulan or Andy or Tesla, and they're all running some processes, each of them running some lints or some builds, some publishing some coils, doing some image manipulation, and then you might have CI. Each time you push something, the CI will run lint, test, build on the affected parts. Wouldn't it be cool if you could save this information? So every time you run some process on your machine or on the CI, all that information goes to your cloud. So the next time when someone runs the same command on the same state of the repo, you just get that information back. Why would you rerun it again? And this saves tremendous amount of time on your machine as well as on the CI. Now, when you look at the commits in your repo, you see something like this. So each time you push something to GitHub or GitLab or whatever you're using, your CI spins up, starts running commands to make sure everything is fine. And then, for example, someone pushed code late in the afternoon, you come to work in morning, you fetch the latest main, you start the build, and instead of running it on your machine, you get the instant replay from the cloud that was done probably by CI the day before. And the same thing is for your colleagues, right? So you build something on your machine, and then your colleague Tesla comes to work or starts working on the same PR. They fetch the code, run the command, they instantly get the information. Now, distributed task execution is something that happens when everything else fails. So the stuff that I was talking about previously, like the affected and the caching, that's fine. But sometimes you make changes to your projects that nullate all of that. So imagine a situation where you, for example, update your core library or bump the version of Node, for example, and suddenly everything is affected. And suddenly you don't have any cache because you haven't run with that version of Node. So all of the cache that you have is just useless at this point, and you have to run everything, like all the builds, all the lints, all the tests. And this then can take a lot of time depending on your project size. So how can we speed this up? When we look at these chunks, let's say we have a large chunk of end-to-end tests and unit tests, we have a chunk of build and then a small chunk of lint. But this is actually not one big blob. We can look at them as a set of small tasks that we need to run, like linting specific files, testing specific suites, or building specific chunks of our code. Normally, what we would do is, since lint doesn't depend on anything, we can run lint first, then run a build, because we might have some of end-to-end tests that depend on the build artifacts, and then that builds can depend on other builds, so we need to make sure they are properly orchestrated. But let's say this is not fast enough. This might take a long time. But we have resources to have more agents. I can say, well, I'm going to buy 2 more agents from my CI provider. So how can I split this work? Normally, you would assume, okay, I'm going to run lint on one, build on another, end-to-end test on the third machine. But when you look at this, you can see there's large chunks of idle time. So how can we make this better? Well, by using distributed task execution, we can calculate how to distribute these tasks so that they spend optimal amount of time. But if you look at this, there's something funny here. If you look at the first agent, you will notice that there's lint, and then there's end-to-end. But how does this one get the build that has been running on another machine? And this is where the caching comes into play again, because we already did it on another machine and stored it in a cache. So that agent just takes it from the cache and replays it directly. And if we need more bandwidth, if we have more resources, we can just scale up. And if it becomes too expensive or we don't care about the speed that much, we just scale down. And regardless of the amount of machines, it will always find the optimal way how to do it. And that's because we know your code, we know what bundlers you are using, and we know the history of your runs, so we can always estimate more or less accurately how long certain things will take. And we know how things are connected, so we can orchestrate it in a correct order. And this is how the agent utilization looks like. So you can see that it's probably too small, but you can see like first one is running 13 tasks, then 14, 17, 12, 14, 20. So each of the machines is running different amount of tasks, but they are almost equally utilized. And this distributed task execution works on all the popular providers, and probably also on providers that are not popular. But you might be thinking to yourself, okay, come on, but how slow can this be? Let me share some sad stories that I heard from a friend. I think this Pablo image is fitting. I was talking to my friend who works at the biggest international organization, and he was asking me, okay, how much can NX save us? I was like, okay, but tell me something more about your project. How long does your bundling take, for example? And then he was thinking for a while. I was like, I'm not sure. I think half an hour. was like, no, not lint, test, build everything. Just build. Yeah, about half an hour. I was like, okay, so when you make change to your API and you want to serve it, you need to wait half an hour. I was like, no. We usually run build at the end of the workday. So the next day when I come to work, I have it all set up. Or if I forget, then I run it in the morning. And then I have like longer coffee break. It's like, but that's crazy. And then we also had a client who had nightly end-to-end tests. The problem was that they keep adding end-to-end tests, and at some point, the duration of the end-to-end tests was longer than 24 hours. So they could no longer run it nightly, it has to be bi-nightly. And although these stories are extreme, it's actually something that happens fairly often. But I know, maybe you don't care about money, you don't care about speed, but perhaps you care about environment, because using monorepos saves a lot of energy from your computer, from environment, so it helps the entire world. One of my friends wanted to say hi, by the way. So I'm going to try to do a quick demo just to show you these things that I was talking about. So this is the application that I was showing previously, and I'm going to just run the graph so that you can see up-to-date graph. So here you can see the image that was previously in the slides. And now I can click on certain things to see how they are connected. And for example, I want to know how Coffee API and orders are connected. So I can click on this link and it says the exact file that is causing this connection. So for example, if you have circular dependencies, you can see just by clicking on the links how this circular dependency is happening. Now, if I go back here, and I'm going to run build everything, you can see that it wasn't running anything. It says 0 projects. And that's because I haven't changed anything. So let's add some console log here. I have some weird language selected. And now let's run the same command again. So now you can see that it's doing some work. And if you look at this, it says existing outputs match the cache. So 8 of them were taken from the cache because I didn't change them. And only one of them, the last one, said that it was changed. Now, what would happen if I would go, for example, to my product list and I do the same change there? And again, run everything. And now we can see that only 5 of them were taken from the cache, and I had to rebuild list because I made a change. And by changing list, product list, I also had to rebuild orders because that was affected, and product list, products, and finally my API. But again, we know exactly what has been changed, and we can tell. And if I would be changing just unit test, I wouldn't be affecting anything else, just the unit tests. So I don't have to rerun everything. And this gives you a tremendous amount of power because now when you change something, you don't have to think about, okay, what could be affected by this change? What should I check? And also, if you're just working on a small chunk of your application, there's no need to check everything, to bundle everything. You just check the stuff that has been changed. So let's recap. You should always split your apps into domains. I know it's easier to work with this big-ass monolith and just stuff everything there and be done with it. But if you split it into chunks, you can really work in isolation. You can bring more people, you can bring more teams, and they wouldn't be stepping on each other's toes. When you split this work, you can benefit from using affected to omit work that is unnecessary. And then you can share the cache, so you don't have to rerun the same thing over and over and avoid double work. And finally, you should distribute work. If you need to build the entire application, but you're working only on one section, Perhaps you can build that section, and your colleague working on another section would build the other section. So finally, when both of you need to bundle the entire application, you wouldn't be doing all the work. Each of you takes a piece of load. So don't worry, I'm not trying to cut down on your coffee breaks. I myself love coffee breaks, and I don't want anyone to stop me from drinking coffee. But I do believe that each one of us is responsible and should be responsible for their coffee breaks and to decide on their own how long and when the coffee break should happen. Not compiler, not bundler, not test runner. Thank you for listening.